G'day and welcome to another Visions of Chaos tutorial. This tutorial is going to cover the DeepDream functionality within Visions of Chaos in more detail. To be able to follow this tutorial, you will need to have installed TensorFlow support in Visions of Chaos. If you have not done this, I link to my other tutorial in the description that covers getting TensorFlow working in Visions of Chaos. Once you have TensorFlow set up in Visions of Chaos, you will notice that you have a new machine learning mode menu. And under that menu, you will see the option for DeepDream. DeepDream visualizes the layers of Google's Inception convolutional neural network that was trained to do image classification. Within the neural network, there are many layers, and DeepDream allows you to see what the neural network is seeing or detecting within each of these layers. Similar to the pareidolia that allows you to see animal shapes in the clouds, DeepDream allows you to see what a convolutional neural network sees or detects within an image. Once you have selected DeepDream from the Machine Learning Mode menu, you will see the DeepDream settings dialog. The first source image setting allows you to specify how the DeepDream display will be seeded. You can choose random noise, the currently displayed Visions of Chaos image, or you can use an external image file. The output image name specifies where the processed image will be saved to. The next setting is DeepDream code. This allows you to select from 3 different versions of code that creates DeepDream imagery. We will now go through these in order. The first version of the code is from Magnus Pedersen. When I first started experimenting with DeepDream, I followed these tutorials from CentDex on YouTube. He used this code from Magnus Pedersen. So if you want to see the exact scripting itself, I link to that in my blog post, as well as a link to Magnus's homepage here. Magnus's code allows you to visualize 10 layers of the convolutional neural network as shown here. Once you have selected Magnus Pedersen in the DeepDream code drop-down, you will then see under the DeepDream layer options that you have these 10 layers to choose from. So as an example, let's see what one of these layers looks like. We'll try the creepy faces layer. We will use a source image of random noise which seeds DeepDream using a random grayscale noise. And so we click process. And if all of your TensorFlow is set up correctly, you will see it start to process the image. On this current PC that I'm running the tutorial on, it's got a NVIDIA 1080, and I've got the current image resolution set to 720p, so it's not too slow. The larger the image sizes go with DeepDream, the longer it takes. So with this example here, it is set for 5 passes with 50 iterations per pass. And so it's currently going through the 5th pass and is almost finished now. Okay, and so that shows this particular layer. You can also use DeepDream to process photos or other images. The way that DeepDream works is it doesn't just apply a texture smoothly across the entire photo. It detects contours and lines and regions of different colors. And so in these examples here, I took this photo of Miss Marple and put it through the 10 layers of the DeepDream here, and these are some of the results. You can see how it has traced the ear shapes and the whiskers, and these breaks here between light and dark areas. And with this third one here, it's a nice example of that. So in this example here, you can see how it's traced around the eyes, the ears. The whiskers are still shown clearly there. As you go deeper within the neural network layers, the image complexity increases. So as this photo shows, using layer 10 gives you much more complex details within the picture. The passes and iterations per pass settings affect how long the DeepDream process is applied to the starting image. If you notice the colors and clarity are not strong enough for your liking, you can try increasing either of these, but for most purposes the defaults are fine. Step size and the rescale factor affect the internal DeepDream processing scripts and shouldn't need changing. You should really only have to change the passes or iterations. Just as a quick demonstration, if we drop the passes down to 1 and process that random noise again, you'll notice that the results are not as clear as the previous result with 5 passes. And so this shows an example of not processing the image for long enough. So if we bump that up to 7 passes and reprocess, so after 7 passes, you now see much more clarity in the shapes and getting larger structures within the result. But as I said, for most purposes, you can leave these settings at the defaults because they're set to a nice balance between processing time and image quality. And that covers Magnus Pedersen. The next DeepDream code I experimented with is thanks to Darshan Bagul, who shares his Halluci network code here. Darshan's code allows all 59 layers of the inception model to be visualized. The other advantage of this code is that the colors are much more rich and output does not suffer from the need for auto brightness that the last method requires. Once you select Darshan Bagul in the DeepDream code drop-down, the DeepDream layers then changes to list the 59 possible layers that you can select and render. If you want to see all the 59 layer images, I link to my gallery here that shows all the separate layer results. You will also notice here that I have got the info for each layer, octaves, iterations, the rescale and the step size values, and so if you want to recreate these you can quite easily by using the same settings in Visions of Chaos. As you see, the colours in these are much more rich and the detail is much higher. Once again, you can also use this DeepDream code to image process photos. Here are a few examples. That one's quite nice. It shows how the DeepDream will follow contours in an image. That one's after too much catnip. That one looks almost a bit disturbing and diseased. Now, as with the previous code, the octaves and iterations per octave control how long the DeepDream processing goes for and will affect how rich the colors are within the final image. Again, step size and rescale factor come into play within the internals of the DeepDream code, and you shouldn't have to mess with those at all. So that covers the Darshan Bagul code. The third code I used for deep dreaming is from ProGamerGov. Who provided the script here. This script extends the DeepDream output even further by allowing multiple channels per layer. So each of the Inception neural network's 59 layers now have multiple channels within them to render. All up, this now gives you a total of 7,548 different DeepDream images to explore, a vast pool of settings to experiment with. To show what all the channels look like, I have a series of sample outputs here. You can see the channel name and settings at the top. The rest of the image shows the channel outputs. As you go down the DeepDream layers, complexity increases. So in this layer here, which is the mixed 4A 1x1 pre-ReLU, you are starting to see much more complex patterns and textures emerging. Again, all of these are referenced, and so if you like a particular image and you want to render it at a larger size or create a movie from it, just take note of the channel number and the octaves, iterations, octave scale and step size settings. If we now go right down to the final layer, you will now notice the images are almost too busy and they're mixing in all the features from previous layers. I've also rendered every one of the 7,548 channel images at HD size. I was originally going to render each layer channel combination as a 4K single image, but after seeing it would take 15 minutes per image, I was looking at nearly 79 days to render all of the example images. And so I dropped back to 1920 by 1080. If you want to see more of the channel images, I've got this gallery linked to from my blog that contains all the various layers, going from the very early layers with little detail, and as the layers increase you get more interesting results. And so you can look through those. Again, if you find a sample you particularly like and want to explore more, they all have got the layer name and the channel setting, octaves, iterations, etc. And so that you can then plug those values into Visions of Chaos and get the same results. When you select ProGamerGov from the DeepDream code, you will see the DeepDream layer now changes to include all of the layers, and they all list a number of channels that they support. For example, the mixed 4D 5x5 pre-ReLU supports channels 0 to 63, which means within this channel number setting here, you can have values between 0 and 63. And so the octaves and iterations per octave are the same as previously. Increase these if you want a more detailed image, or if you find you aren't getting images with enough colors or contrast, or if they're a bit washed out, increasing these can help. Octave scale and step size can stay at the defaults. Okay, so that covers the ProGamerGov code. So now that we've covered each of the DeepDream code options, let's have a look at processing images with DeepDream. A quick note of advice here: DeepDream can take a while to generate on larger images. If you have a not so super GPU, it will take even longer. And so I recommend you start with small sized images to get an idea of the time your GPU will take, then try going for larger images until you reach your patience limit. I was originally going to render all my images at 4K, but once I saw that it would be 15 minutes per image, I gave up and dropped back to HD resolution. Okay, so let's start with processing a Visions of Chaos image. Let's do a Mandelbrot fractal. This area should do. As we covered, we can change between the three DeepDream models. For this demo, I'll stick with the ProGamerGov because that gives the most quality results I found. Let's just pick one of these channels at random. We'll go about mid-range, so it's not too complex but not too simple. This allows channels 0 to 63, so let's just randomly 35. Now we select Visions of Chaos current image as the source, and so that means it's going to take whichever image is displayed within Visions of Chaos and apply the DeepDream to it. So we click process and wait for that to finish. And there we go. Another option here, if we regenerate the Mandelbrot again, is that I've got a bunch of example settings following various themes. So let's try bubbles, see what that does. Okay, so what happened there is that when I loaded it, it changed the source image back to random noise. So let's generate the fractal again, this time keeping the same settings, put that back to Visions of Chaos current image and reprocess. So now that bubble effect has been applied to the picture. So you can experiment with as many of the channels and layers as you wish. Try with different source fractals, other pictures from Visions of Chaos. If you want images like in my example galleries, you have to start from random noise, and then your results will match my gallery pictures where the DeepDream imagery itself is more enhanced. And finally, let's have a look at using an image as the source. For this purpose, you go Other, External Image File, pick your source image, and now you want to resize the Visions of Chaos window to match the source image so it's not stretched out. And so I'm just resizing this to match the source image, and you'll notice that down in the bottom right hand corner of the status bar it shows the image size as I'm changing the window, and so I can just click and drag until it matches the 464 by 400 by 500, which I know is the source image size. So now let's use one of the example files. Let's try eyes 5. Now, when that first loads, it defaults back to random noise, although this will allow us to get a quick idea of what the final result will look like. Since this picture size is much smaller now, this should be much faster to generate. Okay, so this is the eyes pattern which we will apply to the Miss Marple photo. So we can now change that to external image file, which we've already picked the file we want to process, and click process again. Do you want to open? Yes. So there it is there. Now, when other external image file is selected, it changes the iterations back down to 20. In this case, that might not be enough because it's not really processed enough for my liking. You don't want to go too far because then it's just going to show you this like random noise look. But 20 is really not enough to give enough of the eye effect, I think. So let's try bumping that up to maybe 50 iterations per octave and see how that goes. Okay, so there you see how it's starting to take over more, and so that shows there's a balance between not showing enough of the effect and showing too much, and so depending on your photo you might have to play with that setting there, but that gives you an idea of what it can do. Let's try another effect. What about burning 3? Okay, so burning 3 gives us this imagery. So now let's try and apply that to Miss Marple. And I'll put this to 30 this time. So it's just a little bit more than the 20, which wasn't enough, but not as much to overpower. Yeah, that's probably not enough, but you can see certain features are coming through now. Let's try it up to 40. So there, with the extra iterations, it's now showing a lot more of these structures over on this side. Getting a really weird eye shape up here. Okay, so that covers using DeepDream to process photos. You can try any of your own photos or other fractals from within Visions of Chaos. Now, like I said before, try and start with a small size and work your way up to large. If you don't have a really powerful graphics card, this can take a long time. Okay, so that covers image processing. During this tutorial, you have no doubt noticed the DeepDream Recursive Zoom Movie group box here. These settings allow you to make DeepDream movies. Each movie frame output is fed into the next frame input, hence the recursive part. So let's load one of these sample files, maybe gold pipes. And we'll just let that generate. Okay, so these settings create this imagery that looks like shiny gold pipes. So if we wanted to do a zoom movie zooming into this image, you just click Create Zoom Movie. The zoom speed setting determines how fast it zooms in, which is actually how wide each frame is expanded in pixel size. So a zoom speed of 10 means that each frame is expanded by 5 pixels on each side each frame. And so if you make that 20, it zooms in quicker. If you make it only 2, it's a very slow zoom. And so for that, you want to start with random noise. You'll also notice here that once you check the Create Zoom Movie checkbox, the setting for iterations per octave drops down to 20. This is because you don't need as many iterations when doing a recursive movie to get the details to show. So once you've got that checkbox checked, you then just click Process and it will start to generate the frames. So since it's only doing 20 iterations per octave, it's much quicker. You will see it's not doing as much detail to the final image, but since it is recursively fed back onto itself, the network finds those same shapes each time, and so it continuously enhances the picture, which is in this case the gold pipes imagery. I'll let this run for a little while and obviously do some cuts because you don't want to sit here and wait for it to finish with me. So at this size here, it's taking 14 seconds a frame. Okay, so as you can see here, as it zooms in, it continues to find similarly gold pipe structures within the pipes. And so you would normally let this run as long as you like. If you're doing 60 frames a second, it's going to take a while. So for the purposes of this, I'm just going to stop this now, even though it's only been 32 frames. And so once you stop the frames, you will get the build movie settings dialog as per normal. Let's just do a quick one at 30 frames per second. It'll only last for a second, but it'll give us an idea. So that's it there, as it starts to find more and more of the pipes as it zooms in. So you can try the different dream layers, the different channels, different zoom speeds. Let's have a look at these other settings. This setting to increase the layer every 600 frames means that if you are creating a movie with 60 frames per second, after 10 seconds of movie frame creation, it will change the DeepDream layer drop down here. And so as your movie is zooming in, you will notice the effects change. Like here at 20 seconds, you will notice it changes from this reptile snake look into the next layer, which is this effect. So that's done by checking that checkbox. So with the other DeepDream codes that only have 10 or 59 layers, you can then set them to the first layer, click on this increase layer every 600 frames or 60 frames to do it once a second, and then as your movie zooms in, the layer settings will change and you'll get the different effects. Perlin noise flow applies Perlin noise flow to each frame. Now what the Perlin noise does is, we can see this by just going into the image processing Perlin flow. And if you run that, you'll notice it warps and sort of smears the picture around as if it's flowing on a fluid or something. And so with that option checked, this purlin flow will be applied each frame, and so as it zooms it also smears around a little bit. And then the vertical mirror and horizontal mirror does just like it says. If I started a new zoom now with just those two, let's just have a quick look. And so with the mirroring both vertically and horizontally, this will give us a more of a kaleidoscope type effect. The main thing you need to create movies is patience. It can really take a long time. Some of my sample movies took days. That gives you an idea of how the mirroring works. Now, a final feature to explain is this DDS batch button here. You'll see that in my gallery I've got these 4 DeepDream movies which are all based on a certain theme, like eyes related architecture, furry, or trypophobia. The way that these are made is using the DDS batch. So what this does is you can then add these preset files of certain types. So if we want to make a sample, let's say with the feathers related settings, and so this batch mode will load these setting files in turn and then render them for 600 frames, or if you change this to a different value, then longer or shorter. For this purpose, let's just do 60 frames, and so it's just going to last for a second. And so it's now going to load feathers 1, process that for 60 frames, load in feathers 2, process another 60 frames, feathers 3, 60 frames, feathers 4, 60 frames. So let's let that run. Got some previous frames. Again, click OK. Okay, so as you can see, this has got an estimated 1 hour and 14 minutes remaining. I don't think I'm going to let that run through, but that's how you create those movies that are based on a theme. It's all very simple. Again, it just takes time. So I'm going to stop this at that. Okay, that covers everything to do with DeepDream in Visions of Chaos. I hope this was helpful if you are trying to get into DeepDream. If you have any other questions, leave them in the comments. If you have any other feature within Visions of Chaos you'd like covered in future tutorials, let me know. Thanks for watching.